Okay guys, now that we've done boat work and we put that away, we're going to move on with our notes and continue from what we did yesterday. So we've already discussed vertical angles, complementary angles, and supplementary angle pairs. So we know that complementary angles are angle pairs that add up to 90 degrees, and supplementary angles are angles that add up to 180 degrees. So today we're going to go more into parallel lines and transversals that cut through those. So just a reminder, I just kind of gave you the answer, but what are two lines that will never ever intersect? And those will be parallel lines. So when we show that on a diagram, we use these solid arrows placed on the lines to indicate that those two are parallel. So for example, line AB is parallel to CD. So that's what our angles there are for, and we always want to use those symbols like the railroad tracks to indicate which lines are parallel to which ones. If our lines are going to intersect and they are not parallel, we use the same type of symbol but we put a slash through it. So in this case, line AB is not parallel to line CD. Alright, now we've got parallel lines and we've got non-parallel lines. So let's throw in a third line that's going to cut through both those. The line, ray, segment, whatever we're using to cut through those two lines is called our transversal. So on the left here we've got an example of parallel lines with a transversal, and on the right we have an example of non-parallel lines also with a transversal. And then when we have those lines and transversals, we're going to have what's called interiors and exteriors of each. So our interior is kind of how it sounds. It's in between our two lines. And then our exterior is on the outside of our two lines. So our main focus today is going to be the special angles that are created with this transversal. So these can be parallel lines or non-parallel lines. As long as we have a transversal, these angles are going to be formed. So we have interior angles, such as same side interior angles, alternate interior angles. We've got exterior angles, such as same side exterior angles and alternate exterior angles, and then we have what's called corresponding angles. So we're going to go into more detail about what each of those 5 special type of angles are. Okay, so again, reminder, the inside region, the interior region, is what's in between our two lines, or that space in between, like at the top. Then we have the exterior region, which is the outside of our two lines. For example, they're on the bottom in the green. So now applying those inside, interior, and exterior domains to our transversals in two lines. Our interior angles are going to be angles such as 3, 4, 5, and 6 in our diagram there. They're on the inside of our two lines. And then we have our exterior angles, are the 4 angles created on the exterior, the outside of our two lines, such as 1, 2, 7, and 8. Now, to go even further, let's talk about same side interior angles. So same side is going to be the inside of our two lines, and it's just like it sounds, it's on the same side of the transversal. That's going to be very important. So for example, look at our picture. Angles 3 and 5 are same side interior, and angles 4 and 6 are same side interior. Then we also have same side exterior angles. So same thing, same side of the transversal, but on the outside of our two lines. So for example, angles 1 and 7 and angles 2 and 8. Then we'll move on to alternating interior and alternating exterior angles. So alternating interior angles are again the inside of our two lines, but alternating means our angles are on opposite sides of the transversal. So for examples 3 and 6 and angles 4 and 5. Then we have alternating exterior angles, which are 2 angles that are on the outside of our two lines but are on opposite sides of the transversal. These will not make a linear pair. Alternating angles will not make linear pairs. So for example, alternating exterior angles could be 1 and 8 or 2 and 7. And the last thing, kind of the hardest thing for most students to comprehend, is our corresponding angles. So corresponding angles are 2 angles that occupy the same corresponding position So this means that they're in the same spot. So for example, look at angles 1, 2, 3, and 4. They're at the top. To have corresponding angles, we want the angles to be in the same position. So for example, angles 1 and 5 are in the same position. They're on the top left of our 4. Angles 2 and 6 are in the same position. 3 and 7 and 4 and 8 are all in the same position, so they are corresponding angles. Surely that's good enough, right? Oh, I should have stopped.